Hey, this is Professor Elliott. Welcome to our video tutorial lesson on basic logic gates. So here we have an inverter, or frequently referred to as a NOT gate. Okay, the part code, this is a 74LS series. LS stands for low power Schottky. We'll talk about that more in week 5, but the part code, last two numbers, identify this as an inverter gate. So we have an input and an output. The name of the gate gives you a clue as to how it operates. And basically, if it's an inverter, it's providing the inverse, the opposite, the complement logical function. So that means if the input is high, the output will be low. And if the input is low, the output will be high. Okay, there's the truth table. You can see the output is just the inverse than the input. Okay, an AND gate. Okay, it's an 08. 74LS08 is an AND gate. And you can see then that's the schematic symbol. So an AND, how to read this is the output will be 1 if, let's call this input A and input B. If that's 1 and that's 1 and that's 1, output, let's call it Z, will be 1. So we could write the Boolean expression as Z equals A, and then with B, both inputs must be high for Z to be high. Okay, and there's the truth table. The NAND gate. Okay, 0, 0. NAND gate stands for not and, has the opposite function of a NAND gate. Literally, what this is, it's just all in one package, of course, is that they invert the output of an AND gate using an inverter. Okay, so that inverter, okay, so we have a bubble there. That's a bubble, not a solid circle. That output Z will be 0 if inputs A and B are both 1. So the Boolean expression, Z equals A ANDed with B, not, again, that bar means an inverter. Okay, there's the truth table, so you can go over that. And yeah, all this is also online in a printed handout on eLearn for you as well. So anyway, continue on. Okay, the OR gate is the 32. There's the schematic symbol. Let's call that Z. These are just arbitrary designations. It's helpful to call them something. So Z will be 1 if A is high, or B is high, or A and B are both high together. Okay, so the Boolean expression, Z equals A ORed with B, and the plus sign means an OR. Okay, there's the truth table. So the output Z will be high when A is high. It'll be high if B is high. It's also high when A and B are high together. So or high separately. Sorry, Z equals A or B. So they can both be high or any one high, and it will be high. So anyway, NOR gate. It's an O2. Similar to the NAND. This is a NOT OR, like that. Z A B. This is an OR gate fed into an inverter. So this will be Z, this will be A, and this will be B. This will be low, Z will be low if A or B is 1. Z equals A ORed with B, not. Again, that not is because we have an inverter there. Compare that to over there. There's no inverter, so there's no not. Okay. Right, there's the truth table. So Z will be low, right, if A or B is high. In this case, B is high. Z will be low if A is high, and Z will be low if A and B are high together. So again, the Boolean expression, Z equals A ORed with B, not. That's for that final inverter. Okay, the XOR gate is an 86. So this will be Z, this will be A, this will be B. This is a little different than the OR gate. The way this works is that Z will be high if A is high and B is low, or if A is low and B is high. So only one input can be high at a time for the output to be high, which is a little different than the OR gate if you go back and check the table. Okay, so here's the table. So this is our output Z, and the output will be high when only B is high. It will be high when only A is high. But notice then that one, I want to change my color. Here we'll go with, I don't know, green. And the output will be low if both inputs are low, and the output will be low if both inputs are high. So the Boolean expression is Z equals to A plus. This is a plus, must be in a circle like that. Do not simply use brackets like that. That would be wrong. A exclusive ORed with B. Z is A exclusive OR with B. That's the correct expression. Okay. And the last one is a XNOR gate. I don't have a part number for this. I don't think there is one. At least not that I've encountered. But you can very easily create one by taking an XOR gate. You probably got this figured out already, where I'm going with this, right? And feed it into, inverter, like that. Okay, so let's call that Z. Let's call that A. Let's call that B. The Boolean expression is going to be Z equals input A exclusive ORed with input B, all inverted. And that bar has an inverter. So every bar needs an inverter, and every inverter needs a bar. Okay, so this is an XOR gate inverted, which is an XNOR. Notice that the output is high only when both inputs are low, or both inputs are high. Okay, and the output will be low when only one of the inputs is high separately. So it's the opposite function from the XOR gate. Okay, and lastly, this is just a summary pinout of all the basic gates. Okay, so this is a really common, good handout for you to have. I'd highly recommend you bring it to every lab class. Okay, so those part numbers apply to these chips. So as for example, so the 74 LS. And there's a clean copy of this printout online you can print off, so don't worry about it. 32 specifies a quad, which means 4. So there's 1, 2, 3, 4. 2 input OR gates. Okay, now you can use any of the OR gates are the same. You can use one of them or all of them, whatever you need. Make sure you understand the pinouts. Okay, so if you're using, I'm going to just pick one like that. Okay, if I want to use this particular gate, then that's going to have to be pin 1, that's pin 2, and then the output is on pin 3. Very important that you put the pinouts on by each input and output pin on your schematic so you know how to wire it, and your lab professor will be checking for that, and your schematic will be rejected if you don't do that. Okay, so because you can't wire it without the pinouts. So physically, this is a dual inline package. It'll fit right in your breadboard. if that's your breadboard. Okay, make sure it goes on the center channel. Okay, so straddles that, maybe your chip there, it straddles the center channel, and otherwise you just short the whole thing out. Okay, notice that, I need a color pen again. Notice that pin 1, okay, how it's identified by a notch and a dot. Pin 1 is always to the left, okay, then it counts down sequentially and then back up. Okay, for these particular devices, pin 14 goes to 5 volts, pin 7 goes to ground. Don't reverse it, okay, be very careful with that. It doesn't mean every logic chip has that pin out, but these ones, which is mostly what we're working with, do. Okay, so make sure you got this information. And I think that is the end. Great, thanks for coming by, and I hope you got a little bit out of it. Great, thanks, and cheers.